August 1974, the world's largest offshore platform to date. 2.5 years ago, in January 1972, this was just a desolate stretch of beach and an area of sand dunes. This was the site on the Cromarty Firth for a fabrication yard, selected by Highlands fabricators. Scotland won the day for several reasons, among them its proximity to the location on which the new structures were to be placed, Great Britain's offshore oil fields. British Petroleum found the first oil here in British waters. To develop the field, they planned a complex of 4 drilling production platforms. Brown and Root were awarded the contract to design the structures. One of the first 2 platforms was to be built by Highlands fabricators, a Brown and Root Wimpey consortium. The other platform was to be assembled by Lang Pipelines offshore at Greythorpe in northeast England, where they faced the job of clearing and adapting an old dock, a considerable task. For Highlands fabricators, it meant 2 things. First, starting from scratch, they had to create a new graving dock and fabrication yard, a task to be undertaken by Wimpey. This was not a new partnership. Since 1962, Brown and Root and Wimpey have operated jointly on various major projects. The second task was, of course, the whole object of the venture, the fabrication of flotation tanks and structure, the latter usually referred to as the jacket. Brown and Root were responsible for this, and therefore the training of local people, as there was little skilled labour available in the area. Initial recruitment was from the unemployed in the Cromarty Firth district. This training programme has proved very successful. Not only were men recruited from a wide variety of unrelated trades, but also those with existing skills were retrained as welders and riggers. Some of these men had moved south in earlier years. Thus the yard can boast to have reversed the drift from the Highlands in this locality. There are now some 1,000 men who make up what is considered as the core of local residents working here. During the peak of construction activity, there are in excess of 3,000 men employed, and a 3-year youth training scheme is in hand with the local education authority. In the planning of a project of this size, planning permission from the Ross and Cromarty County Council was required, and subsequently the sanction of the Scottish Office. These bodies and the Highlands Development Board gave the project every encouragement and a speedy go-ahead. Brown and Root had a second function, that of project management. The management group set up for British Petroleum was responsible for the engineering design of the jacket itself, a model of which underwent exhaustive tests in Houston. Construction aids, such as the pile handling unit to cope with the giant piles at sea. Procurement of materials, the sheer volume and value of which is a staggering £60 million spent with 17 vendors for this portion of the project alone. Contract administration, the various components for the jacket and modules to be set on the jacket at sea to make up the works of the platform were commissioned all over Western Europe. Here, Brown and Root experience built up in this theatre of operation since the mid-60s was invaluable in smoothing out the problems of fabrication management. Installation. The platforms were to be installed on location by 2 derrick barges, the Thor and Brown and Root's Hercules, both under the operational control of the management group's personnel. At sea, loads of up to 1,900 tons were to be lifted. When the structures were to be set on location, this management team would be drawing on 10 years' experience on the North Sea, a difficult sea and one in which Brown and Root have placed over half the structures, ranging in size from small wellhead protectors to now these giant platforms, the first of their size anywhere. The graving dock's progress to the point where construction could start was dead on schedule 6 months after cutting the first turf. This and the completion of the whole yard ahead of schedule is a matter of great pride to Wimpey. Briefly, they excavated this great hole of Nigg, 1,000 feet long, 600 feet wide and 50 feet deep, 1¾ million cubic yards of sand and sandstone, much of which was used, together with dredge materials for land reclamation. At this time, steel was in short supply. The whole of Europe had to be scoured for it, both for structural members and piling. 7 piling rigs drove 1,200 tons per month. H-piles, rakers, and a total of 4,000 sheet piles along the loading quay face. To give the water a necessary draft at low tide, and to make an approach channel, extensive dredging was carried out. The spoil was used to help reclaim a further area on the west side and create what will eventually be a 160-acre site, where originally there were only 25 acres. In this graving dock, the most spectacular pieces of equipment are the cranes, a fleet of crawler-mounted mobiles and travelling gantries capable of lifting 250 and 550 tons respectively. The giant U marked out on the dock floor is the 56-foot gauge track, which was to give the cranes access to every part of the structure. The problem of flooding by groundwater is ever present in excavations, and in this one the proximity of seawater compounds that problem. Here, the dewatering system has been retained as a permanent method of slope stabilization. To prevent soil slip and wind erosion on the dock slopes, a sand bitumen binding was applied. Major items of equipment were brought in by sea. 14 mobile cranes were the first items to come ashore on the new unloading quay, giving freshly trained riggers their first taste of real action. Cranes had to be cut free, rolled ashore and mobilized. Progress in the training school and the yard's construction had been synchronized to meet the deadline of July 1972. For them, the crane's first job was to unload tank sections fabricated elsewhere and shipped in. September 1972. The structure's flotation system was taking shape. The layman thought of this as the rig standing some 42 feet above the dock floor, but in fact this is only the flotation tank. In the model, the flotation tank is in red and the structure in black, lying on its side and in reality about 300 feet high and almost 500 feet long. The two will be separated at sea once in position and the tank, like the Coke bottle, returned for reuse. Over the summer period of 1972, there was extensive development elsewhere in the yard, construction of stores, offices and fabrication shops. ...200,000 square feet of buildings, of which the fabrication shops took precedence. For inside these structures, the complex welding of component parts for vast marine structures would be done. In fact, by August 1972, these were fully operational and contributed half the nodes for the first structure, Highland 1. For the uninitiated, a node is an intersection of structural load-bearing members of convenient weight for stress relieving. Where units are too big for indoor fabrication, the yard's Texan virtue of wide open space accommodated every shape and size. Twin stress-relieving furnaces, primarily installed for the nodes, can take units of over 100 tons each, carbon steels and most grades of stainless. blasting to clean the steel preparatory for painting. Again, this was outdoors or undercover in the large shop. Next door to shop blasting, the paint shop. Rails linking fabrication in the finishing shops. Every type of non-destructive and destructive testing is in use in the yard. This structural facility would be incomplete without its own source of high-quality, heavy-walled tubulars, the bones of offshore structures. That source of tubulars is the superbly equipped structural steel pipe rolling mill on site. Between rails outside there are 40,000 square feet and inside 65,000 square feet, all this area being served by 3 50-ton capacity gantry cranes. The largest specialty structural rolling mill in Europe. It came on stream in time to make a contribution on the tubulars for Highland 1, the first British petroleum structure. It then started on parts for Highland 2. Capacity is 100 tons per day, more than enough to meet its own yard's requirements, and with good sea, road and rail links, its output can travel so that simultaneously it was engaged on other projects with shipments as far afield as Indonesia. Although primarily for offshore work, the mill can execute almost any order for cylindricals, having the advantage of doing the complete job under one roof. The mill is capable of rolling 3-inch steel cold or an 8-inch thick preheated. During the assembly of the structure's flotation tanks, construction of the entrance works was also in progress. It was to include the longest floating concrete gate in the world. In designing the graving dock, the engineers had used the principle employed by most children at one time or another when playing boats on the beach. A hole is dug for the boat is placed in it, and the water is let in by cutting away the sand between boat and sea. The boat can then be floated out. Here at Nigg, a bund or dyke of sand was left between the hole and the sea. Eventually it would be cut away. The gate was being built so that the dock could be pumped dry after float out and used again. Thus the bund was temporary. The gate would be the permanent means of holding back the sea. Excavators and the dredger removed the bund gradually, pumping the spoil ashore to reclaim a further area to the west of the site. May 1973. Assembly of the structure itself commenced in the dock. The first node was lifted into place. In a little over a year, all the rest of the steel to make the structure was to follow. The method was to make up sub-assemblies for the sides of the jacket on trestles set on the dock floor. All fittings, such as the anodes for the cathodic protection system, were placed at this stage. When completed, each frame was to be lifted, with one side hinging in cradles on the flotation tank. These early lifts were not so heavy as those to follow, 560 tons compared with 940 tons. Nevertheless, one rail-mounted gantry and 7 crawlers combined here to lift accurately without distorting the frame. To get a smoothly synchronized lift, the crane operators were instructed by radio, and the ground in front of their machines was scraped smooth to keep all on the same even keel. Under each crane, the marked guide boards would give the position in the slow trundle forwards as the frame was raised. As was to prove the case so often later, the lift or roll-up started at dusk, ran into nightfall, and was then held until morning for the main part of the action.
Number 155. Number 255. 3, 4, 5, and 6, 70 turns. Number 3, 7.
Next morning, the roll-up continued, despite a high wind, and was accomplished successfully.
Number 7 is 190. Number 5, 70. 6, 70.
winches acted from both banks of the dock. They were to hold the frame firmly in the vertical position at the end of the roll-up.
45. Number 155. 3, 4, 5, and 6, 70 pounds. Number 3, reading 69.
In all, there would be 3 more roll-ups like this one.
Okay, let's get 190, 190.
A month later, the second roll-up has taken place. The first sets of conductor guides are also in position. This is the upper end of the structure lying on its side, and the heaviest lifts of all will take place at the other end. To prepare for this work, the erection of the second and bigger rail-mounted crane had started. These bogies were soon followed by the tower and then the engine housing. This crane would have a 550-ton lift at 70 feet radius. Weather on the Nigg Peninsula can present the visitor with a smiling face, leaving sunshine memories. Nigg Bay, however, can whistle up a wind you can lean on to a rain accompaniment, and the sun can still be shining. Not the best of places to go welding 200 feet up, you might think. Yet examination of the weather statistics for sites further south show Nigg to have no more than its fair share of bad weather. Snow, sweeping down from the highlands, can look dramatic, but this fall in February lay for less than a day. A mile across the water lies the Black Isle, so called because the snow rarely lies there. And if you want to see real live palms growing, take a 2-hour drive from here to the Gulf Stream waters of the west coast. Nigg's weather is no drawback, especially bearing in mind that it is within 2 days' tow of most of the North Sea strikes, well within a weather window of 4 or 5 days. On Highland 1, less than 3% downtime was due to bad weather. February 1974. The third roll-up has been done and the first of the large pile guides placed. These guides have been fabricated by subcontractors off-site and shipped into Nigg. Pile guides and, for flotation tanks, nose cones, all ship-shape and Bristol fashion. March 1974. The fourth roll-up. This took most of the day. The second of the big cranes was now operational, and the pair handled the later, bigger roll-ups together. Yet a third crane came in for the next spectacular lift. One of the Brown and Root fleet of derrick barges, the Hercules, put ashore the buoyancy spheres for the 940-ton lower leg assemblies newly arrived from Germany. Next task for the Hercules, setting and piling 2 dolphins against which the dock gate would be moored when open. The whole site was now finished. The dock, the buildings, the reclaimed land, and the dolphins set. The bund of sand which had stood between the dock gate and the sea long since gone, leaving the gate as barrier to the sea. It functioned perfectly as that barrier. It awaited the structure's completion for its final test. The structure was 80% complete, and July 1974 was now the deadline for float-out. What of the labour force, particularly the local men trained on site? A fabricator once remarked that a welder is a welder on the shop floor, and that when you send him 90 feet up, what then? Structures are bigger now. What when you send him 200 feet up? force was coping. There had been problems, now resolved. There had been few serious injuries and not one fatality, a proud record on a project of this magnitude. At the end of the day, men who a couple of years ago had been farmers, fishermen, salesmen, shoemakers, now riggers, welders, fabricators and scaffolders went home, leaving the world, as the poet said, to darkness and to the night shift. There was round-the-clock working. Although the site can boast ample fabrication space, some of the biggest units can present problems maneuvering past buoyancy tanks. With care, this conductor guide was positioned and lifted. From now on, the biggest, highest lifts were to round off the show. 2 lower leg assemblies weighing 940 tons each. The brunt would be taken by the 2 Clyde gantry cranes. However, an additional high-reach 600-ton capacity was provided by 2 American hoist crawler cranes with skyhorse attachments reaching up almost 300 feet. The first of the lower leg assemblies and 1 sphere were in place by June 74. Each weighed 540 tons and was 51 feet in diameter. The last of the 4 lower leg assemblies. To lift a 940-ton load, it must be kept evenly distributed between the 4 cranes handling it. This is achieved by the type and positioning of the slings. When they moved forward, they had to be synchronized. Any deviation from the correct distribution pattern which developed during the lift had to be spotted and corrected. Failure to do so could have been catastrophic. Inclinometers set on the sides and ends of the load had to register within tight tolerances. And of course, the cranes had load indicators as standard equipment. Here, in a series of shots, is the main movement of the lift. At the top of the lift, the load had to be presented to the structure at the correct angle. Then it was a case of inching it into place and making the best compromise if there were any discrepancy between the cluster, manufactured on the ground in a yard several hundred miles away, and the structure assembled high above ground here. The foreman, in the red hard hat, had to dodge about, radio in hand, to direct the final docking both to the leg on the left as well as to the brace about 50 feet away below. Radio contact with the 4 crane drivers and an assistant stationed inside the closing tubular members eased things for him. Then, with a final close inspection for the fit on top and the inside information from below, the 2 gaps were closed. Incidentally, there was a built-in escape hatch for the assistant's use after the cluster had been set in place. It was well within tolerances. Finally, it was welded into place. Highland 1 was completed by early August, and then final checks commenced on the flotation tank release clamps and the associated hydraulic circuitry. This was to ensure the correct functioning of the various systems required to lower the structure to the seabed. Inside the nose cone of the flotation tanks, the electrical control system underwent exhaustive checks as well. The dock floor was cleared, everything at the ready for flooding. The elements smiled on this royal occasion, August the 14th, and on the 12,000 local people who had attended Highland 1's naming ceremony a few days earlier. On that day, fabrication shops became banqueting halls. And the first employee on the distaff side became the first lady of the day. Though the sun shone and the rain stayed away, there was a wind sweeping up the firth as the dock flooded. Neither the opening of the gate or the float-out could be done in a high wind. The decision was made to deballast the gate on the Thursday afternoon. Pumps emptied the water-filled sections for the gate to lift off the sill on which it had been built. The wind had dropped for the opening, which took 3 hours. By sunset, the gate was safely moored against the dolphins, leaving the dock entrance clear for the structure's departure next morning. Winch out started at 6 a.m. on Friday the 16th, 4 hours before slack high water. Mooring wires held the structure in position, while winches pulled forward at the rate of 6 feet per minute. There was only 35 feet clearance either side. Highland's fabricators' responsibility would cease at the point where tugs took over from the winches. From now on, Brown and Root British Petroleum Management Group were to supervise the tow and setting on location. Out in the main channel, the installation contractor and Brown and Root's Marine Division took the structure in tow. It dwarfed 2 of the world's most powerful tugs, which were assisted by 2 smaller ones, keeping it stern on to the ebbing tide before starting the tow. 200 miles to location at a speed of between 2 to 4 knots. At 1 o'clock that afternoon, Highland 1 passed through the Suitors, the mouth of the Cromarty Firth, and Nigg experienced the mixed feelings common to all shipbuilding communities at this juncture, pride and regret. The latter tempered by the thought of the imminent start to be made on her sister, Highland 2. On the following Tuesday morning at 8:20, the project manager's team on the nearby control boat initiated the flooding of tanks by radio control. The crash dive took 45 seconds. At that time, this was the biggest steel structure ever to be set